Good morning everyone. Welcome back to the session on permutation and combination. In the previous session I have discussed with you the concepts of permutation, also the basics of factorials and the fundamental principle of counting. In this class I will be discussing with you the concept of combination and the formulas of combination with some of the example questions to complete this entire topic of permutation and combination. So the goal for the class is to understand the topic of combination, what is combination all about and what are the different formulas of combination, and to discuss and develop concept through problem discussion. Clear? Alright, so what we'll do is we'll start straight away with combination. What is combination? Why is it different from permutation? So combination, you can say combination is selection. Combination deals with the selection, not with the order. So in combination, the number of ways in which something can be selected, that is important. The order is not important. So order is not important. The selection is important, not the order in which we take the name of the things that have been selected. Order is not important. If you see in permutation, we have discussed that permutation deals with arrangement, and in permutation order is important, like questions on letters and words, questions on numbers. When we change the order of the letters, the word changes, the meaning changes. However, when we change the order here, we don't get a new meaning. Let's say if we talk about two persons in a classroom and they are friends, let's say Amar and Ajay are friends. So I have taken the name of two persons. I have made a selection out of the two, or in the class, let's say of 10 or 20 persons, I made a selection of two persons, Amar and Ajay, and I am saying that Amar and Ajay are friends. Now there is a particular meaning that this sentence conveys to us. It tells us that these two persons selected from the class are friends. Okay. Now if I change the order of their names, if I change it to Ajay and Amar, and I say Ajay and Amar are friends, will this change the meaning of the sentence? Will it give us anything new? Is it giving any new information to us? Are these two sentences giving anything different from each other? No, they are giving us the same information about two persons, Amar and Ajay, and saying that they are friends, and that is because order is not important here in this particular situation. Say two persons are there, Ram and Vijay, and they are going to see a movie. Say Ram and Vijay are going to see a movie, or if I say Vijay and Ram are going to see a movie, again there is no difference in which we take the names of the persons. Suppose three persons in a class are selected to participate in a quiz. Let the three persons be A, B and C, and one person comes in the class and announces that A, B and C are selected from this class. Or he says that B, A and C are selected, or he says that C, A and B are selected. It does not matter in which order he takes the names of the three persons. Ultimately what we know is that these are the three persons who have been selected for the particular program. So this is what we mean by combination. The selection is important, the order is not. Clear? And what type of questions are there which are based on combination? See, if you look at keywords, any question that talks or has the word select, in how many ways we can select something, in how many ways we can choose something. So next is any question that deals with the word choose. Here, in how many ways we can select, in how many ways we can choose or pick something. Let's say there are 10 red color balls in a bag and I have to select 3 balls. I have to pick 3 balls from a box or a bag. That's again a question of combination. If I have to choose 5 persons from a class to represent a team, then that's again a question of combination. And same way, if the word select is there, that's again a question of combination, because combination deals with selection. Also, you see any question that has the word group, how many ways we can make a group of 5 persons or a team of 5 persons, in how many ways we can make a committee of 5 men and 6 women. So all of these keywords are there that should indicate to you that you are dealing with a question of combination, just like we have keywords for permutation, like digits, letters, numbers, words, arrangement, seating arrangement. All of these are keywords that instantly tell you that this is a question of permutation, whereas The keywords select, choose, pick, group, team, committee. These are keywords that tell you that this is a question of combination. But see, from school days I have been observing that the students learn permutation and combination. They learn the formulas and they solve the questions, but ultimately they get confused about whether this question is a question from permutation or is it a question from combination. So where they have to use NPR, they start using NCR and vice versa. Ultimately they get the wrong answer, and in a competitive examination, wrong answer does not mean that you just get 0, you get negative marks. Okay. So this is why I am stressing so much on understanding what is permutation and making you understand what is combination, and also giving you the keywords. These keywords will help you in identifying. The moment you see the keyword select, choose, pick, group, team, committee, you will know that this is a question of combination. So you can just then recall what formula of combination will be used, use the formula and get the answer. Okay, that's about combination. What is combination? Deals with selection of things, and in combination order is not important. In contrast, permutation deals with arrangement of things, and in permutation order is important. So in a question where you cannot decide based on keywords, you should decide based on whether order is important in that question or order is not important in that question. Alright. So what we will do is we start with the first formula of combination. R things can be selected from n distinct things in NCR ways. So again we are talking about distinct things. Understand, it's very important. If things are not distinct, then the question of selection does not happen. Okay, we have to select only when things are not distinct. So R things can be selected from n distinct things, different things, in how many ways? NCR ways. Where C stands for combination, just like P stands for permutation. N is the total number of things, and R tells you about the number of things that have to be selected. So that means, what is, first of all, let's see what is the formula NCR. What is NCR? So NCR is equal to n factorial divided by R factorial into n minus R factorial. This is what we mean by NCR. Okay. Now if you compare this with the formula of NPR, what can you observe? Now if the formula of NPR, what is the formula? NPR is equal to n factorial divided by n minus R factorial. Now for the same value of n and R, which will be greater? Will NCR be greater or NPR be greater? If you look at NPR, we are dividing n factorial by n minus R factorial. Whereas if you look at NCR, we are dividing n factorial by n minus R factorial into R factorial. So in NCR, the denominator is bigger. Both NCR and NPR have the same numerator, but NCR has a greater denominator. That means for the same values of n and R, NCR will always be less than equal to NPR. That's one important key observation that you must keep in mind. Number of permutations will be greater or equal to number of selections. Now what other ways are there in which NCR and NPR can be linked? You see, if you take NCR, n factorial by R factorial into n minus R factorial, and if you multiply it with R factorial, what will happen? If you multiply with R factorial, the R factorial part will get cancelled, and that will become equal to n factorial by n minus R factorial. Now what is n factorial upon n minus R factorial? It is NPR, and this entire thing here is NCR. So can we say that NPR, number of permutations, will always be equal to number of combinations multiplied with R factorial. So this is another important observation and important result to remember. So two important things to understand here: the comparison of combination and permutation. Overall, this is the main formula of combination. In how many ways you can select R things from n distinct things? The answer is NCR. let's say for example there are 10 boys and 6 girls. In how many ways you can select a team of 4 boys and 2 girls? You have to select a team, you have to make a team. You have to make a team of 4 boys and 2 girls from 10 boys and 6 girls. So the ways we can select 4 boys from 10 boys, 10C4, and means multiplication. Number of ways in which you can select 2 girls from 6 girls, that is 6C2. So the answer will be 10C4 into 6C2. If you want, you can simplify this. 10 factorial by 4 factorial into 6 factorial into 6 factorial by 2 factorial into 4 factorial. 6 factorial can get cancelled, and then we can simplify this entire thing. 10 factorial divided by 2 factorial into 4 factorial whole square. If you want a numerical answer, you have to put the values and get the answer. But this is the overall understanding. How do we use the formula of combination that's in front of you? Main observation, first of all, main thing is, what is this formula? So we say NCR is equal to n factorial. This is the first thing you must understand. NCR is equal to excuse me, NCR is equal to n factorial by r factorial into n minus r factorial. Now comparing with the formula of permutation, the second important thing that we have understood here is that for the same values of n and r, NCR will always be less than equal to NPR. Then how to get NPR from NCR? This is the third thing that we have understood today in this particular slide, that NPR is equal to NCR into r factorial, that is number of permutations is equal to number of combinations multiplied with r factorial. Alright, this is the first formula for combination. Lots of things we have understood. This is the main formula. Almost 70 to 80% questions in exams are based on just this one formula. Okay. Now let's look at the second formula. R things can be selected from n identical things in how many ways? I have left this empty. Compare here, R things, same thing, R things can be selected from n distinct things. Here R things can be selected from n identical things, you see. One second. Just let me restart here. The slide seems to have stuck. Okay. Let me start the PPT once. Okay. All right, let's go back here. So we have seen earlier that this NCR formula stands for, one second, just let me check the, all right. Okay, so we ready now? So NCR formula we have seen, NCR is equal to n factorial by r factorial into n minus r factorial. Also we have understood that NCR will always be less than equal to NPR, and that NPR is equal to NCR into r factorial. Okay, these are the main three things we have seen. Now continuing with this technique, now next one is R things can be selected from n identical things in how many ways? So we have R things here, but the number of things from which I am selecting is identical. I have left it empty for you to understand that this can be done in only one way. There is no choice in front of us. When choice is not there, it does not matter what or how many things are being selected. R things are being selected, but the number of ways in which you can do it is only one. Let's take a practical example. Let's say you have a box of Minto Fresh. Now normally we will have mints, Chlormint or Minto Fresh, Mentos, you know. When you go to a shop, you see there is a jar in which a lot of Minto Fresh are there, or Mentos, whichever you prefer. Now all of these mint candies, 50 paisa mint candies, all of them look identical, clear? but look identical, all of them are same. So if you have to take 2, are you going to search for which 2 you want, or you will just pick any 2? Any 2 you pick will give you the same result. That is why we say that R things can be selected from n identical things in only one way. Okay, that is about this particular formula, this particular concept. Now let's see the third one. 0 or more things can be selected from n distinct things in how many ways? Now here we have distinct things, so there will be number of ways in which it can be done. But we are not selecting a fixed number of things. We are not saying R things. Okay, we are saying 0 or more things. 0 or more things can be selected from n distinct things in how many ways? Let's say we pick up 0 things, we get NC0. That is one option that you have. You can select 0 out of n, or you can take 1. So that means, or means addition, or you can select 1, so you get NC1, or that means again addition, you get NC2, selecting 2 things from n, or selecting 3 things from n, and so on till you select NCn. And you should know that this total is equal to 2 power n. Okay, this is basically nothing but the sum of the coefficient of a binomial expansion. That is an advanced concept of algebra, something called as a binomial expansion, a plus b power n, which is equal to NC0 a power n plus NC1 a power n minus 1 into b power 1 plus NC2. This formula that I am writing here is called binomial expansion. You don't have to remember this formula, just understand. We go on doing till we get NCn b power n, and in this formula when you put a equal to 1, b equal to 1, the left hand side becomes 2 power n and the right hand side becomes NC0 plus NC1 up to NCn. You don't have to worry about the derivation, just remember the result here. 0 or more things can be selected from n distinct things in how many ways? 2 power n ways. Clear? So that is one important thing. For example, you have to select 0 or more apples from 5 distinct apples. How many ways you can do it? 0 or more apples from 5 distinct apples. From 5 distinct apples, so all the apples are distinct from each other. Normally we say 5 fruits, it means they are distinct. Okay, so 0 or more apples from 5 distinct apples, how many ways we can do it? Simple, the answer is 2 power 5, that is equal to 32. Clear? Now let's go to the next formula of combination. 1 or more things, so again we have now not 0, 1 or more things from distinct things. So number of things are distinct, same as the previous formula, except the only change is that we don't have 0 or more here, instead of that we have 1 or more. Now we know for 0 or more we have NC0 plus NC1 plus NC2 so on till NCn, and this is 2 power n. You just have to remember 2 power n, that is for 0 or more. When we say 1 or more, then we exclude the case of selecting 0. I don't want this. So what I can do is I can take it on the left hand side. So we get NC1, NC2 up to NCn, selecting n things from n things is equal to 2 power n minus NC0, and NC0 anything combination 0 is equal to 1. So what is the answer? 2 power n minus 1. You just have to remember this value, don't worry about the derivation. So 1 or more things from n distinct things is 2 power n minus 1, whereas 0 or more things from n distinct things is equal to 2 power n. Clear? Let's say there is a basket which contains 5 apples, 6 oranges and 4 bananas. If the question does not say anything, fruits have to be taken to be distinct. The basket which contains 5 apples, 6 oranges and 4 bananas. In how many ways you can pick? In how many ways you can pick some fruits? In how many ways you can pick some fruits such that you have at least one fruit of each type. We are adding a condition here, one fruit of each type. You are not going to select 0 fruits, okay? You have to select at least one fruit of each type. That is what is important here. In how many ways you can select some fruit from the basket which contains 5 apples, 6 oranges and 4 bananas, such that you have at least one fruit of each type. You are not allowed to select 0 apples, you have to select at least one apple. Similarly, you cannot select 0 oranges or 0 bananas. So, one or more apples we can select in 2 power 5 minus 1 ways, one or more oranges in 2 power 6 minus 1 ways, one or more bananas in 2 power 4 minus 1 ways. That is equal to 31 into 63 into 16, and then you can solve this and that will be your final answer. Okay. So, that is how we use this formula, that one or more things can be selected from n distinct things, very important, one or more, and also to understand that the things are distinct in how many ways? In only in 2 power n minus 1 ways. If it was 0 or more, what was the answer? 2 power n. A brief example is here below for you to understand when and how to use this particular formula. Alright. Let us look at the next formula here, the fifth one from combination. 0 or more things can be selected from n identical things in how many ways? Now we have seen that when you select r things from n identical things, there is only one way, because the things are identical, there is no choice. Whichever two, let us say for example of the Minto Fresh, 2 Minto Fresh I had to select, whichever I select the result will be same. So there was no choice of what to select, and that is why the number of ways of making the selection was 1. Here also the things are identical, there is no choice in terms of what to select, but we have choice in terms of how many to select. Also, although we do not have a choice of what to select, you have a choice of how many to select. That means there will be some number of ways, and 0 or more things can be selected from n identical things in n plus 1 ways. Okay. Let us understand this here. Suppose there are 4 mint candies in front of you, 4 mints, all are identical mints are there in front of you, and you have to select 0 or more. What options you have? If you do not like mints, you will say I will take 0, I will not take mint, I do not like eating mints, you will take 0, or you will take, okay sir, we will take 1, or you can take 2 mints, or you can take 3 mints, or you can take all the 4 mints. The total how many ways are there? You have 5 ways. That is why we have 4 mints, we have 4 plus 1 5 ways. When we have n identical things, select 0 or more things, then the number of ways will be n plus 1. That is the fifth formula for combination. So identical things, the formula is different, for distinct things the formula is different for the same situation. Next, if we have 1 or more things, not 0 or more, we have 1 or more things from n identical. So this is supposed to just add here, okay, n identical things. Again, so let us take the same example. You have 4 mint candies, all are identical. Now when we had the option of selecting 0 or more mints from the 4 mints that we had 5 options, take 0 or 1 or 2 or 3 or 4, right? We had 5 options, but the moment I say 1 or more, we cannot take 0 now. So now how many options are there? 4 options are there, 4 ways are there. That means when we have n identical things and we have to select 1 or more from n identical things, the number of ways will be n ways. Clear? So these are the 6 formulas that you need to understand for combination. Now when we have 1 or more things, we have to select 1 or more from n identical things in number of ways will be n ways. Clear? So these are the 6 formulas that you need to understand for combination. 6 formulas that you need to understand for combination. 6 formulas that you need to understand for combination. right? So all the formulas, you can look at them once again, observe what we're doing, what is the difference between the different formulas, what happens when we have distinct things, what happens when we have identical things, accordingly use. Although in the exam point of view, if I'm talking about, then the most important formula is the first formula. 80% questions come from the first formula in the banking examinations, and that formula is that R things can be selected from n distinct things in NCR ways, and NCR is equal to n factorial by R factorial into n minus R factorial. So now we have the previous session contest question. In how many ways can you send invitation to 5 friends through 3 servants? 5 friends are there and 3 servants are there. In how many ways we can do it? Suppose I say, let's consider servant 1. The servant 1 can go to any of the 5 friends. There are 5 options, 5 friends are there. Servant 1 can go to any of the 5 friends. So there are 5 ways of doing it. What about servant 2? Okay, servant 2 can also go into any of the 5 friends. So 5 ways. What about servant 3? Servant 3 can also go to any of the 5 friends. That's 5. If I multiply here 5 into 5 into 5, then the answer is 5 cube. But is this right or wrong? Let's observe this. If servant 1 goes to any of the 5 friends, he is the first one to go. Okay, so we decide to invite. I decide to invite 5 of my friends. I ask my first servant to go and give a card to one of the friends, or I ask him to go and give card to 2 of the friends. Clear? Now when servant 2 decides to go, when I ask servant 2 to go and give cards to some of my friends, servant 2 need not go to those friends to whom I have already sent servant 1. Those friends who have already received invitation from servant 1, we cannot send invitation again from servant 2. So this approach becomes wrong, because servant 2 cannot go to any of the 5 friends. It depends on whether servant 1 has gone to some of them or not. Clear? Similarly, servant 3 also cannot go to any of the 5 friends, because again it depends on whether servant 1 and 2 have already invited them or not. So we cannot think in from the point of view of servant to friends. Rather what we should, so this entire answer is wrong. Rather we should think from the point of view of friends to servants. Let's take friend 1. Friend 1 can receive invitation from any of the 3 servants. It does not matter who comes to him. Ultimately the objective is that he should receive the invitation. Similarly, friend 2 can also receive the invitation from any of the 3 servants. Similarly, friend 3 can receive invitation from any of the 3 servants. The same is true for friend 4. It does not matter who comes and invites him. Each friend can receive the invitation from any of the 3 servants. Clear? So that means all servants cannot go to the same friend. Clear? All servants cannot go to the same friend, but all friends can get invitation from the same servant. Okay. So 3 into 3 into 3 into 3 into 3, that's 3 power 5. Always people get confused with respect to 5 power 3 or 3 power 5. Please understand, the answer is 3 power 5. So this interesting question from, you can say it's a permutation question. Now let's go to this contest type. Contest question for this session. What is the number of rectangles in an 8 into 8 chessboard? Right, you've seen an 8 cross 8 chessboard. There are 64 squares there. I'm not asking you about the number of squares. I'm asking you the number of rectangles. So can you find out the number of rectangles in an 8 cross 8 chessboard? At least the hint I can tell you is that all squares are rectangles. See, a square is a special rectangle where the length and breadth are equal. Okay, so don't assume that a square is not a rectangle. The answer is not 0 first of all, that I'm telling you. Now think about how can you use the concept of combination or permutation for finding out this answer. What is the number of rectangles in an 8 cross 8 chessboard? I'll be discussing the solution for this question in my next video session. But you should try finding out the answer and post the answer in the comment section to see how many of you can find Now continuing with the topic of combination, the seventh formula of combination. Now this is an advanced level formula of combination that deals with dividing things into groups. The number of ways of dividing m plus n different things into two groups containing m things and n things respectively. Total how many things we have? M plus n. We are dividing them into two groups, one containing m thing, one containing n thing. Number of ways will be equal to m plus n factorial divided by m factorial into n factorial. But here we have one case. Now you have to keep this case in mind, and that is if m equals n. If m equals n, then the answer will become equal to m plus n factorial divided by m factorial into n factorial into 2 factorial, because the two groups are identical. The two groups are not identical, no need to divide. For example, let us say if there are 20 students in a class and you have to divide them into two teams. One team containing 12 students and one team containing 8 students. 12 plus 8, 20. We are dividing them into two groups, 12 and 8, and 12 is not equal to 8, so we can directly say the answer will be 20 factorial divided by 12 factorial into 8 factorial. That will be the answer for this question. However, suppose we had, let us say we have a pack of cards, and a pack of cards contains 52 cards. Now you divide the cards in a pack of cards into 4 equal groups. So if you are dividing into 4 equal groups, that means each group will contain how many cards? 13 cards. So there are 4 equal groups, 13 plus 13 plus 13 plus 13, that is equal to 52. And dividing the 52 cards into 4 equal groups. So the number of ways will become equal to 52 factorial by 13 factorial into 13 factorial into 13 factorial into 13 factorial into 4 factorial, or we can say it will be equal to 52 factorial divided by 13 factorial to the power 4 into 4 factorial. Okay, that is what we have to understand. Here I am taking m equal to n, or m and n things. You can take p things, q things and r things also. So we have p plus q plus r things divided into groups of p things, q things and r things respectively. Then the answer will be p plus q plus r factorial divided by p factorial into q factorial into r factorial. If p is equal to q is equal to r, then you have to further divide by 3 factorial. Okay, so this is normally an advanced question from the point of view of banking examination, but you never know, exams can behave in a very unpredictable way. Sometimes suddenly a tough question comes which has not come before, and then students are thinking what to do about this now, this was not covered before, now this is a surprise for me. We should not be waiting for surprises, at least we should cover up all these advanced concepts also. So in case you get a question directly based on the formula, you can get the answer in just 10 seconds. Put the formula, get the answer. At least it will not be a completely new thing for you. That is why we are discussing all of these advanced concepts also. Tomorrow you are not having anything that is a surprise for you. If you know, people are there, students are there who are not just touching the topic of permutation combination nowadays, because it has not come in 2015, it does not come in 16, 17, so it will not come in 18. That is not there. There is no such guarantee or certificate from IBPS or SBI that this question will not come. A question of permutation combination in a very different way can be asked in the examination, clear? Or it can come back, and it can come at a difficult level also. So be prepared with everything, don't take any risk. When you prepare for examination, be more than 100% ready for it, know every possible question that can come in the examination and be ready to crack the examination. Don't wait or depend on chance and luck. Okay, alright. Now if you see here, what apart from this m plus n things, what we need to really helpful concept for you, that is important results. Some important results are there and if you know these important results, it helps you a lot in solving questions on permutation and combination. Okay, particularly we are talking about combination results, not permutation. So combination formulas we have seen, combination results, let's understand these results. First one is that NC0 is equal to NCN is equal to 1. That means if I select 0 things from n distinct things, or if I select all things from n distinct things, the number of ways of doing it is only 1. Also, if you put this in the formula, you will get 1 as the answer. So NC0 is equal to NCN is equal to 1. The second result is that NC1 is equal to NCN minus 1 is equal to n. Then the third one is that NCR is always equal to NCN minus R. Clear? For example, 6C2 will be equal to 6C4. You see, 6 minus 2 is 4. So NCR is equal to NCN minus R. 6C2 is equal to 6C4, or 10C3 is equal to 10C7. That you should understand. Now the fourth result is this, that if NCA, let's write it like this, if NCA is equal to NCB, NCA equals NCB, and A is not equal to B. So A and B are not same, because if A and B are same, obviously NCA will be equal to NCB. So I will say 4C2 is equal to 4C2. There is nothing surprising about that. Okay. Now we are talking here about when NCA is equal to NCB and A is not equal to B, then we can say N is equal to A plus B. We can find out N by adding A and B. So this is an important result to remember. For example, let's say it's given to you that NC4 is equal to NC6, then NC2 is equal to how much? Okay, that's the question. So if NC4 is equal to NC6, and we can see clearly that 4 and 6 are not same, that means N is equal to 4 plus 6, that is 10. And once we know that N is equal to 10, we can say NC2 here would mean 10C2, and 10C2 is equal to 10 factorial by 2 factorial into 8 factorial, that is 10 into 9 into 8 factorial by 2 into 8 factorial. We can cancel 8 factorial, 2 and 5, 9, okay, 5 into 9, 45. So what is the answer? 45. So this is the fourth important result that we have to remember regarding permutation, regarding combination. NC0 is equal to NCN equal to 1, NC1 is equal to NCN minus 1 equal to n, NCR is equal to NCN minus R. If NCA is equal to NCB and A is not equal to B, then N is equal to A plus B. One more result you can remember is this, that NC2 will always be equal to N into N minus 1 by 2. That is direct formula, so that we do not have to do this. We have to find 10C2. 10C2 is equal to 10 into 9 by 2, that is equal to 45. So this will save you time. You do not have to do all this calculation. You will get the answer directly if you know that NC2 is equal to N into N minus 1 by 2. So 5 important results for you to remember that can be used in questions in exams. For example, let us say there are 10 teams. Let us say there are 10 teams in a tournament where every team has to play, every team has to play every other team exactly once. So what is the total number of matches? What is the total number of matches. Okay, so this is an application of combination. What is the total number of matches that will be there? So every team has to play with every other team exactly once. So whenever we have a match, what is the number of matches? Whenever we have a match, we have to have 2 teams. Now from 10 teams, 2 teams can be selected in how many ways? 10C2. So number of matches will be equal to 10C2, and NC2 is equal to n into n minus 1 by 2, that is 10 into 10 minus 1, 9 by 2, and that is equal to 45. What is the answer? 45. Clear? Suppose there are 20 persons in a room and each person has to shake hand with every other person exactly once. Total how many handshakes will be there? 20C2. Okay. So these kind of questions, if you know the results, you can do it directly, easily. You can calculate and find out the answer. So all the formulas of combination I have discussed with you. The most important formula is the first formula. It is R things can be selected from n distinct things in NCR ways, and NCR is equal to n factorial by R factorial into n minus R factorial. What is more important is to understand the difference between permutation and combination. Understand that combination deals with selection where order is not important, whereas permutation deals with arrangement where order is important. I have given to you the keywords also that are there in permutation and combination, and then the different formulas which are required to solve questions. Admittedly, since last 3 years, permutation and combination have not been coming in any bank examination, so it is not a very high priority topic, but we must at least know the basic formulas, have a basic acquaintance with the topic, basic familiarity. You should know the formulas, what type of questions are there, so that tomorrow if the question comes back, you should not be completely lost in the examination paper. You should know the basic formulas, you can try out the questions. That is the purpose why we are covering this topic for you, so that you are more than 100% ready for your examination. So now the time for the class practice pack, in which I have selected 10 questions from combination that will give you a good practice of all the formulas that I have discussed in this particular session. Those who have passport access can start solving the question once you hear the sound, right? Solve the questions, use the techniques discussed in the class, and you will see that most of the questions you can solve, right? So best of luck to you and thank you.